Binomial Expansions Part 2. You should have a look at Part 1 before continuing with this video. In Part 1 we look at expansions of this form where the power is a positive integer and you have a finite number of terms in the expansion. So in the expansion of 1 plus x to the power of n, the power can be a fraction, it can be positive or negative. Basically, n can be any real number. This must be 1 plus. If it's not, we can factorize out something first to make sure that this is a 1 plus. We'll start off by looking at x here, but it doesn't have to be x. You can have any of these. You could have a 3x here, a minus 5x, an x squared, an x cubed, and so on. You get an infinite number of terms in the expansion, and typically a question will tell you to work out the first 4 terms, as an example. Now, for the expansion to be valid, this condition must be true. So in its simplest form, it's saying this, that this term x must be between minus 1 and plus 1. But let's say if we're not using x here, but if we were using 3x as an example, then this must be true. And if this is not true, then the expansion would not be valid. And typically what you would do here is you would divide by 3, so you get this. Another way of writing the same thing is the size of x is less than a third, or the magnitude, or its modulus. Some examples of what we can expand. Now here's the formula that we're going to use. It's given in the formula book, and there's a pattern to the terms. So if we went for the next term, so we've got the first, second, third, fourth term, the fifth term in the expansion would be n times n minus 1 times n minus 2 times n minus 3 over, and you can see 2 factorial, 3 factorial, this would be 4 factorial. You can see x, x squared, x cubed, this would be your x term to the power of 4. Example 1. We need to rewrite this first in this form, and using this formula, the first term will be 1 plus, the next term is n times x, so I have to multiply these two together like this, and then the next term will be n times n minus 1 over 2 factorial times x squared. So I've got all this. So here's the n from here, and this is n minus 1 over 2 factorial times x squared, and the next term will be n times n minus 1 times n minus 2, and remember n is minus 1, so that's n minus 2, over 3 factorial times my x term, whatever I've got here, cubed. And simplified, I have these terms. Now the expansion is only valid if this is true. And again, all this is saying is whatever you've written there must be between minus 1 and plus 1. It must take a value in that interval. If the value of x is outside this interval, then the expansion is invalid. And you can see that we have 1, 2, 3, 4 terms worked out here up to the x to the power of 3 term. There are more terms, there are an infinite number of terms. Example 2. Now the first issue we've got here is there's a minus there. We need a 1 plus right there to use the formula that we used in the previous example. So that's easily taken care of like this. So we have a 1 plus. So in the expansion we start with 1 plus, there, 1 plus. then n times x, we have to multiply these two, and remember x in this case is minus x in brackets, like this. And then n, which is a third, there, 1/3, times n minus 1 over 2 factorial, and again my x term must be in brackets, squared, and then we can simplify. So my simplified terms, and the expansion is valid for my x term, which is minus x, so to be less than 1, so its modulus, or its magnitude, must be less than 1, which basically simplifies to this. The long version of this is here. So I'm starting off with this, and whatever you see here right in the middle, and it's between -1 and +1, so I've multiplied by -1 throughout. We have inequalities, so multiplying by a negative number you have to reverse the direction of the inequalities. So I've multiplied everything by -1, and now that this is correct mathematically, but it's better written in this form, and that is saying that the magnitude of x is less than 1. Example 3. So the first term, 1. Second term, n times x. There's the n. There's the x term, so n times x. And then third term, n times n minus 1 over 2 factorial times x squared. There's the n. There's the n minus 1 over 2 factorial. Remember to put the x term in brackets, squared. You've got to put brackets in. This is actually 16x squared when you expand the brackets. And then you've got your final term, where you've got n minus 1, n minus 2 over 3 factorial times your x term cubed. And then simplify all of these. We get these terms, again an infinite number of terms, and the expansion is valid if the magnitude of my x term, so that's 4x, is less than 1. I can just divide by 4, that's the easy way. Again, the slightly long version would be to write 4x between -1 and 1, and then divide by 4. And then realize that this is actually the same as this. For practice, have a go at these questions.